Assalamualaikum warahmatullahi wabarakatuh. Today, I would like to present a brief profile of a key automotive product and the company behind it. The product we are highlighting is the Petronas Long Life Radiator Coolant Premix. This high-quality coolant is designed for engine temperature regulation and protection. In our field study, this specific product was documented at a Petronas station located at lot 1227, Jalan Mencara, Nilai Impian, Nilai 7180. Next, let's look at the manufacturer. The Petronas LL Radiator Coolant Premix is produced by Petronas Lubricants International Sdn Bhd with the company registration number for 85509T. Petronas Lubricants International is a major player in the global lubricants industry, and their corporate headquarters are located in the iconic Tower 1, Petronas Twin Towers, Kuala Lumpur City Centre, 50088, Kuala Lumpur, Malaysia. This central location underscores their position as a leading Malaysian entity with a significant international footprint, which is further highlighted by their involvement in high-performance sectors like Formula One racing.
The Petronas Long Life Radiator Coolant is specially designed to keep a vehicle's engine's cooling system working efficiently. Its main function is to cool the engine by transferring excess heat away from the engines to the radiator. This helps prevent the engine from overheating, especially during long drives or in hot weather. Besides cooling the engine, the radiator coolant provides long-lasting protection against rust and corrosion inside the cooling system. Rust and corrosion can damage important engine and components, so these coolants help extend the lifespan of the radiator and the entire cooling system. In addition, the coolant protects metal components from wear and corrosion. It also protects the mechanical seal of the water pump and thermostat, which are essential parts that ensure cooling system operate properly. Another important feature is that it protects rubber and aluminium components from damage. This helps maintain the durability and reliability of the cooling system over time. Furthermore, the product meets and exceeds Japanese Industrial Standards or JIS and ASTM standards, which mean it has been tested to meet high quality and performance requirements. This radiator coolant is suitable for both petrol and diesel vehicles, making it versatile choice for many types of cars. It's also free from harmful substances such as amine, borax, and silica, making it safer for modern engine cooling
Next,
system.
I'm going to present the chemical ingredients found in Petronas LL Radiator Coolant Premix. Let us start with the base fluid. The primary functional ingredient here is ethylene glycol, which has the IUPAC name ethane 1,2-diol. Structurally, it is a simple 2-carbon alkane chain with 2 hydroxyl alcohol groups attached to the first and second carbon. Next, we move into the corrosion inhibitors. Petronas LL uses organic acid technology or OAT. A key component of this technology is potassium 2-ethylhexanoate. Chemically, this ingredient consists of potassium cation ionically bound to a 2-ethylhexanoate anion. Its structural backbone is an 8-carbon branch chain fatty acid, where a 2-ethyl group is attached to the main hexanoate chain. Next, sodium 2-ethylhexanoate, which you can see in this slide. Its structure is practically identical to the previous ingredient, except the potassium ion is replaced by sodium cation. It features the same 8-carbon branch chain fatty acid structure. Next, the formulation uses methyl 1H benzotriazole. It is important to note that this ingredient is actually a mixture of isomers, meaning they share the same molecular formula but have different structural arrangements. This is the first isomer, which known as 4-methyl-1H1,2,3-benzotriazole. It consists a triazole ring containing 3 nitrogen atoms fused to a benzene ring. In this specific isomer, the methyl group is attached at the 4th position of the benzene ring. To complete the formulation, we have the second isomer, which is 5-methyl-1H1,2,3-benzotriazole. The fundamental structure remains the same, which is a triazole ring fused to a benzene ring. However, the methyl group is now attached at the 5th position of the benzene ring.
The second organic chemical ingredient in this engine coolant is ethylene glycol. It is the main component responsible for regulating the engine's temperature. ethylene glycol belongs to the alcohol class of organic compounds, so more specifically, it is classified as a diol or 1,2-diol because it contains two hydroxyl or OH functional groups attached to adjacent carbon atoms. So the IUPAC name of ethylene glycol is ethane 1,2-diol. So its molecular formula is C2H6O2 and its chemical structure consists of a two carbon chain with a hydroxy group attached to each carbon, and it can be written as OH CH2 CH2OH. So this simple structure gives ethylene glycol its excellent heat transfer and antifreeze properties, making it the primary organic ingredient in the engine coolant.
Glycol formation. Now, I would like to explain the reaction mechanism for the formation of ethylene glycol, which is the main organic compound used in this radiator coolant product. Ethylene glycol is produced through the hydrolysis of ethylene oxide. In this reaction, ethylene oxide reacts with water in the presence of either an acid or a base catalyst. The mechanism shown here illustrates the base catalyzed reaction where the hydroxide ion acts as the nucleophile. Step 1. Nucleophilic attack and ring opening. In the first step, the hydroxide ion attacks one of the carbon atoms in the ethylene oxide molecule. Ethylene oxide contains a three-membered epoxide ring which is highly strained because the bond angles are much smaller than the normal bond angle of an sp3 carbon atom. Due to this ring strain, the epoxide ring is highly reactive and can be opened easily. The hydroxide ion donates a pair of electrons to one of the carbon atoms. This process opens the ring and produces an alkoxide intermediate with a negatively charged oxygen atom. This step is known as a nucleophilic ring opening reaction and is similar to an SN2 mechanism because the nucleophile attacks the carbon atom directly. Step 2. Protonation. In the second step, the alkoxide intermediate reacts with a water molecule. Since the oxygen atom carries a negative charge, it is unstable and tends to attract a proton from water. The alkoxide accepts as a hydrogen ion or proton from the water molecule. As a result, the negatively charged oxygen is converted into a hydroxy group while the water molecule loses the proton. This proton transfer stabilizes the intermediate and prepares it to form the final product. Step 3. Formation of ethylene glycol. After proton transfer is complete, the final product formed is ethylene glycol. The molecule contains two hydroxyl or OH group attached to two adjacent carbon atoms because it contains two alcohol functional groups. Ethylene glycol is classified as diol. Its IUPAC name is ethane 1,2-diol and its molecular formula is C2H6O2. The overall reaction converts ethylene oxide into ethylene glycol through ring opening followed by protonation. Importance of the reaction. This reaction is very important in industry because ethylene glycol is widely used as the main ingredient in radiator coolants and antifreeze solutions. Ethylene glycol helps lower the freezing point and raise the boiling point of the coolant, allowing the engine cooling system to operate efficiently under hot and cool conditions. In our product, Petronas Long Life Radiator Coolant, ethylene glycol is the main organic chemical ingredient. However, the final product is not made of pure ethylene glycol alone. It is mixed with deionized water and several additives such as corrosion inhibitors, stabilizers, and coloring agents to improve its performance and protect the radiator system. In conclusion, the mechanism begins with the nucleophilic attacks of hydroxide on the strained epoxide ring of ethylene oxide. This opens the ring to form an alkoxide intermediate, which is then protonated by water to produce ethylene glycol. The ethylene glycol is then used as the primary organic compound in the manufacture of radiator coolant.
The production of long-life radiator coolant begins with the preparation of raw materials, including ethylene glycol, deionized water, corrosion inhibitors, anti-foam agents, stabilizers, and green dye. The glycol is mixed with deionized water in a stainless steel mixing tank until a uniform solution is formed. Next, additives are introduced to protect the cooling system from corrosion, rust, cavitation, and foam formation. The mixture is then homogenized under controlled conditions to ensure consistency. Samples are tested for pH, density, glycol concentration, freezing point, boiling point, and corrosion resistance to meet quality standards. After passing quality control, the coolant is filtered to remove impurities before being filled into bottles, sealed, labeled, and batch coded. Finally, the finished products are packaged, stored, and distributed for commercial use.